In question number 6, question says figure shows volume temperature diagram for two ideal gas A and B. If the number of moles of gas A is 3 times that of gas B, then the ratio PA is to PB is. Since this is a volume temperature graph, so we know that volume by temperature will be equal to NR by P. So we can say that the slope of A will be equal to the volume of A by temperature of A, that will be equal to the number of moles of A into R divided by pressure of A. But according to the question, slope of A is 60 degree. So we can write this will be equal to tan 60, and tan 60 will be equal to the number of moles of A into R divided by pressure of A. Right? Similarly, slope of B, if I write the slope of B, so slope of B will be equal to the number of moles of B into R divided by pressure of B. So slope of B is 30 degree. So we can write tan 30. Right. So tan 30 will be equal to NBR upon PB. So if I divide equation 1 and 2, what we will get? So if we divide, we will get tan 60 is root 3. So root 3 divided by tan 30 will be equal to 1 by root 3, will be equal to, right hand side R will be cancelled out. So we can write NA upon NB into pressure is in denominator. So they will get reversed. So we will write pressure of B divided by pressure of A. So left hand side we will get 3, and according to the question, number of moles of gas A is 3 times that of gas B. That means number of moles of A will be equal to 3 times of number of moles of B. So NA by NB will be equal to 3 into pressure of B by pressure of A. So 3 will cancel out. So you will get pressure of A by pressure of B will be equal to 1. So our option number 3 will be the correct choice. Now let's move to the question number 7. In question number 7, it says that if 1 mole of monatomic gas is mixed with 1 mole of diatomic gas, then the value of CV by CP. Listen, CV by CP, not CP by CV. So we have to calculate the CV by CP, and we know that CP by CV will be equal to gamma, and that can be written as 1 plus 2 by F, where F is the total degree of freedom of any gas. And we know that for monatomic gas, degree of freedom is how much? 3. And for diatomic gas, degree of freedom is 5. Right? So since they are mixed, so first we will calculate the degree of freedom of the mixture. So degree of freedom of the mixture can be calculated by simple formula N1F1, that is the number of moles into degree of freedom, plus N2F2, that is the degree of freedom into number of moles of 2, divided by total number of moles, that is N1 plus N2. So this is 1 mole. So we can write 1 into 3. This is again 1 mole. So we can write 1 into 5 divided by 1 plus 1. That will give you 4. So that means degree of freedom of the mixture is 4. So from here we can say that the Cp by Cv of the mixture will be how much? Will be equal to 1 plus 2 by degree of freedom of the mixture. So how much you will get? 1 plus 2 by 4. So you will get 3 by 2. But what we have to calculate? We have to calculate Cv by Cp. So Cv by Cp will be the inverse. So that means 2 by 3. So my option number 2 will be the correct choice. Now let's move to the question number 8. In question number 8, it says that the volume expansion coefficient of an ideal gas at constant pressure is observed as gamma is directly proportional to T to the power n. The value of n is. Since this is at constant pressure, and we know that at constant pressure volume will be directly proportional to temperature. So let's say we write volume will be equal to some constant into T, right? So do you know what is the volume expansion coefficient? The volume expansion coefficient can be written as change in volume per unit volume per unit change in temperature. That means change in volume per unit change in temperature. So this is called our volume expansion coefficient, that is gamma. So from here we can say that our dV by dt will be equal to what? K, right? Since V is equal to KT, so dV by dt will be equal to K. So if I put the value here, so here this is a dV by dt. So we can write K divided by V. So V is KT. So K will cancel out. We will get T to the power minus 1. So if I compare this equation with this, so we can say that the value of N will be equal to minus 1. So my correct option will be 2. Now let's move to the question number 9. In question number 9, it says that a fixed mass of ideal gas is taken from the state A to B along a straight line in pressure temperature diagram. Select the incorrect option. So this is the pressure temperature graph. And since it is passing through origin and it is a straight line, so we can say that this graph represents pressure directly proportional to temperature. And if the pressure is directly proportional to temperature, we can say that volume will remain constant. Right? So from this graph, we got two relations. First, pressure directly proportional to temperature and volume remains constant. Now let's look at the options. Question says that slope of line AB from temperature axis is inversely proportional to the number of moles of the gas. We know that pressure will be equal to NR by V into T. So if I write in the form of Y is equal to mx, so if this is our Y, this is our x, so this will represent our slope. So from here we can say that if this angle is theta, so slope tan theta will be equal to what? Slope tan theta will be equal to NR by V, right? Slope of the pressure temperature graph. So according to the question, so according to the option 1, the slope is inversely proportional to the number of moles, but slope is directly proportional to the number of moles. So this is our wrong statement. Second, work done on the gas is 0. Yes, since volume is constant, so work done will be 0 because work done is what? P dV integration. So if the volume remains constant, so yes, work done on the gas is 0. Density of the gas is constant. So we know that P is equal to rho R T by M. This is also in one of the ideal gas equation. So we can write rho will be equal to Pm by RT, but pressure by temperature is the slope and it will remain constant, so density will also remain constant. So this is also our true statement. This is also true, this is also true, right? Option number 4, slope of line AB from temperature axis is directly proportional to the number of moles of the gas. Yes, slope is directly proportional to number of moles, so this is also correct. So we can say that our option number 1 is the correct choice. Now let's move to the question number 10. In question number 10, it says that in simple harmonic motion, if x, a and t denotes the displacement, acceleration and time period of particle respectively, the value of at square by x. So we know that acceleration can be written as omega square x, right? So a by x can be written as omega square in SHM, right? So if I write at square by x, the value of at square by x will be equal to omega square t square, and we know that omega is how much? 2 pi by t, so we can write 2 pi by t whole square into t square. So t will cancel out, so you will get 4 pi square. So we can say that the value of at square by x will be equal to 4 pi square, and which is constant. So we can say that our option number 3 will be our correct choice. Now let's move to the question number 11.